In this lesson on volume, I want to kind of go for logical reasoning to help you understand the volume formulas, because they really are very logical. You can also just memorize them. Here they are. The 6 that you need to know are for a prism. Rectangular prism, you could actually use this formula: volume equals the area of the base times the height. This is just a special kind of prism. The cube, again, you can use the area of the base times the height, or you can use side times side times side. Pyramid and cylinder and cone are a little bit different, and we'll talk about those separately. The biggest idea is, if you can figure out the area of the base of a figure and multiply it by the height, that'll have something to do with the formula. If it's a regular figure that holds its shape all the way through its height, like the cylinder that has an area of a base, but it holds its shape through the entire height, then you can take the area of the base and multiply it by the height. That doesn't work when you have a figure like a pyramid, where you can figure out the area of this base, which is a 2 by 2, so the area of this square pyramid, base of the pyramid is 4 square units, and the height is 3. You can't just multiply the 4 square units times 3, because it doesn't hold its shape. It's sort of irregular as it goes up through this. So there's a special formula for that. But here's the rationale for it. And I love the alphabet blocks for demonstrating this. Oops. So, well, we'll just let that go, but I'll pick up the other one. This is a cube, 1 cubic unit. This is 1 inch by 1 inch, so the area of this part right here is 1 square inch, and then you multiply it by the other dimension, and you get a cubic inch. 1 inch times 1 inch times 1 inch gives you a cubic inch. So when I make this rectangular prism, the area of the base is 4 square units, and the height is 1, so if I follow this formula, actually I can just do 2 times 2 times 1. 2 times 2 times 1 would give me the 4 cubic units that you see here. And then if I pick up the pieces here, if I stack another 4 on top of it, which is going to be even a trickier move than the one I was doing earlier, I just double the volume. Oh well, you get the idea. I'll try this. So on a little platform here, I have a 2 by 2 by 2, which will give me 8, and obviously you count them. You get 4 on the bottom, 4 on the top, or 2 layers of 4, maybe it's a good way to look at it. 2 layers of 4, or the area of the base being 4, 2 times 2, times the height gives me the idea that I can multiply the area of the base times the height. And I can, if I do a cube, the simple formula is multiply the width times the height times the length, and you get 2 times 2 times 2 again, that's another 8. So that's the formula for a cube. For a pyramid, I think I'll talk about cone first, because I can actually demonstrate it. The area, the circular base of this cone is the same as the circular base of this cylinder, so they're kind of related to each other. If I wanted to figure out the area of the cone, I could use, of the cylinder, I could just find the area of the circular base, which is pi r squared, and then multiply it by its height, because this is a regular kind of figure that holds that area all the way up through. This is probably about 2-inch radius, so it would be roughly 3 times 2 squared, and the height is 4. So 3, using 3 for pi, so 3.14159, make it simple. 3 times 2 squared, which would be 4, 3 times 4 is 12, times the height, which is 4, would be 48 cubic units. I could actually take this cylinder, which is related, it has a height of 4, which is the h in this formula, the distance from the, if I went from the tip to a point on the bottom, directly below the tip, that would be the height of the cone. I know from experience that I could take this cone and fill it 3 times with water, and it would come to the top of the cylinder. So there's 3 times as much volume in this cylinder as there is in this cone. So if I found the area of the cylinder, which is pi r squared h, and divide it by 3, I would get the volume of the cone. I think I said area of the cylinder. I meant to say volume, find the volume of the cylinder, divide it by 3, and I would find the volume of the cone. And it's related to the formula for the volume of a pyramid. If I take the area of the base, which is a 2 by 2, so it's 4 square units, 4 square inches, then the height is 3. So I can do the 4 square units times the 3 units, which gives me cubic units, 12 cubic units, and divide it by 3. 12 divided by 3 gives me 4. So the area, the volume of this pyramid, the square pyramid, would be 4 cubic units. You always have to be multiplying to get volume. It's always cubic units, so you have to be multiplying 3 dimensions together. Here you see it length, width, height, side, side, side. You look here, you might say, well, there's not 3 measurements multiplied together, but capital V stands for the area of the base. So that's going to be, in the pyramid, it's probably a length times a width. So it's really a length times a width times a height. So there are 3 things that are multiplied together. Always have cubic units when you have volume, like you have square units when you have area.